So welcome back to our series on gases, and today we're going to look at the combined gas law. So what do we know so far? We know that the volume and pressure are related at a constant mass and temperature. This was Boyle's law, which was P1V1 is equal to P2V2. We know that temperature and volume are related when the mass and the pressure are constant, and this was Charles' law, which was V1 over T1 is equal to V2 over T2. So Boyle's law and Charles' law may be combined to give us a useful gas equation. This gas equation is called the combined gas law, and it's written P1V1 over T1 is equal to P2V2 over T2. And what this equation looks at is the interdependence of the three different entities that we're looking at, which is volume, pressure, and temperature. So the combined gas law states that for a constant mass of gas, that the volume is proportional to the temperature divided by the pressure. So let's have a look at some questions you might encounter that would involve the combined gas law. So a 13-litre container of oxygen gas at 6.1 atmosphere pressure at 25 degrees C is heated to 85 degrees C and compressed to 19 atmospheres. What is the new volume? So let's have a look at what we've got. I have 13 litres, there's a volume. I have 6.1 atmospheres of pressure at 25 degrees C, a temperature. Then I have a second temperature, 85 degrees C, and a second pressure, 19 atmospheres, and a second volume I'm looking to find. So I'm looking at my P1V1 over T1 is equal to P2V2 over T2. Let's find out who our ones are and who our twos are. So I see 13 litres at 6.1 atmospheres at 25 degrees C. So these three are linked. Okay, this volume, this pressure, and this temperature are all linked together. So they're going to be my V1, my P1, and my T1. And then that's going to be heated to my T2, my P2, and my V2, which I'm going to be looking for. Okay, so let's fill these in. So my P1, 6.1 atmospheres, my V1, 13 litres, and my T1, it was 25 degrees C, but I know I must convert this to the Kelvin scale. In case you've forgotten how to do that, absolute temperature is the Kelvin scale. And to change from degrees Celsius to Kelvin, all you need to do is add 273 to the Celsius value. So for example, in this case where I have 25 degrees C, add 273 to it, and you get a 298 Kelvin value. If, for example, it was 4 degrees C, again, just add 273 to it, and you end up with a Kelvin temperature of 277. So any Celsius temperature you get, just add 273 to it to get your Kelvin scale. So for my P2 of 19 atmospheres, my V2 I'm looking for, and my T2 is 85 degrees C, but I need to convert that to the Kelvin scale, and that becomes 358 Kelvin. I now need to transpose this equation so that I have my knowns on one side and my unknowns on the other side. So I want to transpose it with respect to V2. So when I do that, my 358 becomes multiplied by the 6.1 atmospheres and the 13 litres, and the 19 atmospheres then becomes divided by, as you can see here. If you plug all these values then into your calculator, so 6.1 times 13 times 358, all divided by 298 and 19 atmospheres. Look at your units of measure. There's an atmosphere on the bottom on the top, they cancel out. There's a Kelvin on the bottom on the top, they'll also cancel out, which means your remaining unit of measure is going to be litres, which is volume, and it is a measure for volume, so we know we're on the right track there. Putting all those numbers in, we should get a value of 5.01 litres for our V2. Let's have a go at another one. A sample of hydrogen gas occupies 4.25 litres at 63 degrees C, and now the pressure is being measured in millimetres of mercury, which is 1,140. What volume will it occupy at 105 degrees C and 2,280 millimeters of mercury? So what do I have? I have a volume 1, a temperature 1, I have a pressure 1. These three are all linked together. They can't be separated out. So they're all my P1, V1, and T1. What's the new volume? That's my V2. There's my temperature. That's my T2. And there is my pressure, my P2. And I'm going to fill them into this equation, which is P1 V1 over T1 is equal to P2 V2 over T2. So there's my pressure 1, there is my volume 1, and there's my temperature 1, which is 63 degrees added to 273 to bring it to the Kelvin scale of 336 Kelvin. There's my pressure 2, the volume that I'm looking for, and my temperature 2. Just like before, we're going to transpose this equation to get the V2 on its own and all my knowns to the other side. This is where the units will help you. If you're not used to dealing with atmospheres, perhaps, or millimeters of mercury, you will see in this instance it doesn't matter because the units will cancel out. Millimeters of mercury on the bottom and the top will cancel out. The Kelvin on the bottom and the top will also cancel out, therefore leaving my unit of measure in liters. So plug all these values in, 1140 multiplied by 4.25 multiplied by 378, all divided by 336 times 2280. And the answer you should get then will be 2.39 litres. I want you to have a go at this one. If a sample of carbon dioxide gas occupies 0.5 litres at 90 degrees C and 3 atmospheres, what volume will it occupy at STP? So in case you haven't heard of STP before, STP stands for standard temperature and pressure, which the standard temperature is always 273 Kelvin. This is the equivalent of 0 degrees C. But remember, whenever we're dealing with gases, we must always use the absolute scale, which is the Kelvin scale. We will never use degrees C. So your standard temperature will always be 273 Kelvin. The standard pressure is 1 atmospheres. Now this is interchangeable depending on the unit of gas that is in the question. So for example, I'm dealing with atmospheres here, so I will use 1 atmosphere of pressure as my standard pressure. Now 1 atmosphere of pressure is equal to 760 millimeters of mercury. If this question had used the units millimeters of mercury, then I would use my standard pressure as 760 millimeters of mercury. But because it's using atmospheres, I'm also going to use atmospheres, so I will use my standard pressure as 1 atmosphere. So have a look at what your pairing is there. So I have my 0.5 litres, there's my V1, my T1 90 degrees C, and my P1 3 atmospheres. I am looking for a V2, and I have a T2, 273 Kelvin, and I also have a P2, which because I'm using atmospheres, I'm also going to use the atmosphere equivalent here, which will be 1 atmosphere. So given that information, I want you to fill it into the P1 V1 over T1 is equal to P2 V2 over T2, and try it yourselves. Pause this video, see how you get on, and then you can check your calculations, which are given in the next slide. You can see from this slide, the answer should have come out as V2 is equal to 1.13 litres. And just as a final example for you to try, a 30 ml cylinder has a gas at a pressure of 445 millimeters of mercury and a temperature of 20 degrees C. The gas is heated to 35 degrees C and transferred to a new cylinder of volume 75 ml. What is the pressure in millimeters of mercury of the gas in the second container? So let's see what I have. There's my V1, there's my P1, and there's my T1. Don't forget to convert that to the Kelvin scale. Then I have a T2, convert to the Kelvin scale. I have a V2. What I'm looking for is my P2. So fill that into your equation, have a go, and then check your answer then on the following slide. So we can see here that P2 is equal to 187.11 millimeters of mercury. which was answer A on the previous slide. So that's it today for combined gas laws. Thank you very much for joining me.